Hi guys, welcome to Deep Diver. In the last video, we have discussed statically typed language versus dynamically typed language and also weakly typed versus strongly typed language. We have seen why Golang was chosen as statically typed and strongly typed language. In this video, we will be discussing syntax, techniques and best practices related to variables. Let's start. This is my VS Code and here I will add one more folder for doing this variable related coding. Let us name this folder as 2 underscore variables, and here I will add a new file. We can name this as variables.go. The first thing in a Go file is we need to provide the package name. So here we'll give the package name as main, as we want to create an executable out of this file and run the code as well. And when we give the package name as main, then we must have this main function. Now let us look into how we can declare variables. In Golang, you can declare variables using two ways. First is using var keyword and another way is using this colon equal operator. Let us first look into the first way. So to declare a variable using var keyword, first you give the keyword var, then the variable name and then the type. Then you can initialize it with some value. Here it is giving a compilation error that this variable name is declared but not used. So let us use this fmt library, and from this fmt library we will use the function printf, which can be used to format a string. And then I need two things here. First is the type of the variable, which we can get using %t, and the value of the variable, which we can get using %v. And then we'll add a new line just to keep the output clean, and corresponding to this %t and %v, we need to pass the argument to this printf function. In this case it is name and name. Here we are still getting a compilation error that this fmt is undefined, so we need to import this fmt library. If you save this code, VS Code will automatically import this fmt library. Now let us go to terminal and run this code. So currently I am inside this Golang course directory. Let me change it to 2 underscore variables. Now let us run this code using this go run command. Go run variables.go. So we have our output name, which we have printed, and %t, which was for type, so type is string, and the %v, which was for value, so value here is Modi. If you have worked with languages like C, C++, or Java in the past, then this Golang variable declaration might feel weird to you at first, because in those languages we will declare the same variable something like this: a string, name and then Modi. So in those languages we first give the type and then we give the variable name, but here it is reverse. Here we are first giving the variable name and then the type. Let me try to make it less weird for you. So how do we read English in our day-to-day life? From left to right, correct? Try reading this Golang variable declaration from left to right. You can read it very easily. Variable name of type string. Try doing the same thing for this declaration of other languages where the type comes first and then the variable name. You will struggle here. You can read it like a variable of type string with name, which is not so straightforward. So this Golang variable declaration mirrors how we read English in our day-to-day life, which is left to right, which basically improves the readability of the code. Now let me try to add some more variables. Here we have added a string variable. Let us add a integer variable. I will name this variable as age and data type will be int. So here you can see multiple flavors of int 16, int 32, int 64, int 8, but we will keep it simply as int. Now my question is, as we have seen there were multiple flavors of integer int 16, int 32, 64 and 8. So how much bits this int will take? So this depends on what type of a machine you are. If your machine has 32-bit CPU architecture, this int will take 32-bit. But if your machine is 64-bit architecture, this int will take 64 bits. So let us move forward and add more variables. This time I will add a variable of type float. So float comes in two flavor, float 32 and float 64. We'll take here float 64. We'll assign some value here. We'll have one more variable, let us say of type boolean. This time I will name this variable as isMarried, and boolean is represented by bool in Golang, and I will initialize with value true. We are again getting the same compilation error, declared and not used, and we will use these variables in a print statement. So let me copy this print statement and paste it. So here I will replace name with age, age, age. In the next line, let us print the salary, and at last we'll print isMarried. If I run this code again, we have our output. Name is of type string with value Modi, age is of type int with value 76, salary is of type float 64 with value 100.5, and isMarried is of type boolean, which is represented by bool with value true. Here in this declaration we have used where keyword as well as the data type, but Golang provides you the flexibility of declaring a variable using this where keyword, where you can get rid of this data type. So let me show you that. Let me copy this code and then comment it, and then I will paste the same code. So I will get rid of all these variable types. So I got rid of variable types. Now let me ask you one question. In the last video we have discussed Golang is a statically typed language, which means type checking happens at compile time, and the compiler must know the type of all these variables. But here we have not given the type of any of these variables. So how will the compiler determine what type of variable these are? So there is a concept called type inference, which the Go compiler uses to decide the type of each of these variables. So this type inference works like this. It looks at this variable declaration and checks what type of value is getting assigned to this variable. For example, for this name variable, it will see the value type is a string, so the Go compiler will infer the type of this variable as a string. Similarly, for age, the Go compiler will see that it is getting assigned an integer value, so it will infer the type of this age variable to be integer. Similarly, for salary, it will see a float type value is getting assigned to this salary, so it will infer the type of the salary as float. Similarly, for isMarried, it will see a boolean type value is getting assigned, so it will infer the type of this isMarried variable to be boolean. So now let us try to run this code. Clear go run variables.go. So you can see we have the same output here, right? Now let us look into the other way of declaring variables, which was using that colon equal operator. Now let me copy this code and comment it and then paste it again. So here we can get rid of this where keyword, get rid of all the where keywords which we have used for these variables, and replace this equal with colon equal, colon equal, colon equal, and colon equal. So you don't see any compilation error here. If you run this code again, you will see the same output getting printed here. So this is the two ways by which you can declare variables in Golang. Till now we have declared variables on a different line. So to declare these 4 variables, we have consumed 4 lines in total. What if I want to declare all these variables on a single line? How can I do that? So we can again do that in 2 ways, either using where keyword or using this colon equal operator. So let us try to do that first using this where keyword. So we will use the keyword where, and then we give all the variable names, name, age, salary, and then is married, and then we'll give their corresponding values. Modi 76, 100.5, and true. Let me comment this former code. If I run this code again, you will see again we have the same value here. So one thing I want to tell you is, here again we haven't used any type for all these variables. And how is the type decided for each type of variable? Using the type inference. So compiler uses the type inference again to determine the type of each of these variable. Now let us see how we can do that using this colon equal. So just get rid of this where keyword and replace this equal with colon equal, and we'll have our code running. So you can see we have the same output here. One more thing I want to tell you is, when we have used this where keyword, we haven't given the type here, right? But even if we want, can we give the type here? The answer is no, because each of these 4 variables are of different type. So we cannot give any type which can be applicable to all these variables. Let us say we wanted this age and salary both to be integer, then we could have written like age salary of type int, and then we could have given the value 76 and let us say 100. Okay, let me get rid of this age and salary from here. Okay, so that would have worked. Let me run this code again. Go run variables.go. Oh, it is giving error. We haven't removed the values from this side. So let me run this. So again we have our output. This time this salary is also integer with value 100. So if we have multiple variables of the same time, then we have the option of either we can give the type or we cannot give the type. But if we have variables of different type, then definitely we cannot give the type. I hope this makes sense to you. Now let me undo this change. So till now we are good here. Now let me introduce you to one more concept. Let me comment this code. Let me copy paste this code which we have used initially. So here let me uncomment this, and initially when we declared our variable like this, we have provided initialization value to all these variable. Like this name variable is getting initialized with value Modi, this age is getting initialized with value 76, and the salary is 100.5 and is married to true. What if I don't give the initialization value here? Let me remove all the initialization value for these variables. Now what do you think the output will be? Will it be a garbage value or anything else? So when you declare a variable in Golang without initializing it, it will take the zero value. So what is zero value? For a string, the zero value is an empty string. For integer, the zero value is 0. For float, the zero value is 0 again. And for boolean, the zero value is false. So if I run this code again, you will see the zero values for all these variables. So let me do that. Go run variables.go, and you can see name is of type string, but you don't see anything here because the zero value of a string is empty string. That's why you don't see anything here. For age, the zero value is 0. For float 64, the zero value is 0 as well. For is married, the 0 value is false. So far we have talked about variables value that can change. For example, this age variable can be reassigned any integer value any number of times. For example, we can first say age is equal to 10, then age is equal to 100, and so on. Now let us talk about constants, values that cannot change. How can we declare a constant in Golang? So to declare a constant in Golang, you can do it like this. You first use the const keyword, then you give the constant name. Let us say the constant name is pi, and then you need to assign it a value. So here if you see, if I try to reassign some other value to this pi constant, or even the same value to this pi constant, you will see a compilation error here, cannot assign to pi. So whenever you want to declare a constant in Golang, you need to use this const keyword. So let us declare some more constant. Const, again let us say pi2. This time I will give the value as 22/7. So this will also work. Now let us say I am trying to declare one more constant. Let us say square root of 2, and giving the value as math dot square root of 2. So here I am basically using this square root function from math library, but here you will see an error. What is the error? Math dot square root of 2 value of type float 64 is not constant. So the rule for declaring a constant is the value should be known at the compile time. Here on this line 34, the compiler has all the values. It just needs to do a division operator, and whatever the value of this 22/7 will be, that will be assigned to pi2. But here we are calling this square root function from this math library, which will only be executed on runtime. That's why you see a error here. Math dot square root of 2 is not constant. So to fix this, you need to provide the value which can be calculated at compile time only. So we can give it value like 1.41. So that will work. So now let us try to print the value of this constant as well. Let us print this first. Now I'll copy this, copy paste, copy paste, copy paste, and first is pi, then pi2, and then this is square root of 2. Let me clear this and run the code again. So here you see pi is float 64 with value 3.14. Pi2 is now int, because this 22 was int and this 7 was int, so this division operator has also produced an int, so its value is 3, and now square root of 2 is float 64 with value 1.41. With this video has come to an end. Thanks for watching and see you in the next one.